One of the most requested topics of discussion since we initially shared this most recent catalog and forelooking analysis of VEI 7 volcano threats has been for more than the somewhat intellectually unsatisfying and broadly qualitative description of the current risk of such an event on Earth. Here, I'd like to share some quantitative facts about these eruptions and show how recent history actually contrasts with the ultimate findings of this paper. First, they state that these big ones are happening about twice per millennium, about once every 500 years. But this requires going back in time thousands of years to when you see large gaps beginning to appear between events, where you begin to suspect that they might have missed one or it happened under the ocean, etc. There is no question that the last 4,000 years or so of VEI 7 eruptions is well known, and they do indeed match the accepted catalogs here. So let's look back over just that period and see that the last few thousand years has something a bit different to tell us. Here we see no time greater than 380 years between such events, and if you consider that maybe the 30-year event was unexpectedly early and explained the longer one, indeed, we appear to be ticking at a much faster clip of such eruptions lately, with one occurring about every 200 to 300 years. These century scales are approximate, may have been 196 or 305 years, but essentially when you look back through their data and the gaps get longer and longer, you have to know they're probably missing some, and so the numbers are skewed such that they do not represent recent reality, which is indeed that we are creeping into that period where another one might be expected. So let's find some more numbers, shall we? The average VEI 7 release of material is about 75 to 100 cubic kilometers of material, of Earth. But when we look back over those eruptions we just mentioned, we can see that there is a deficit of late. The last three have been smaller than expected by about half, and certainly represent a deficit compared to the previous VEI 7 events on that list. By this measure, which could be considered as cubic kilometers deposited into the atmosphere and then later onto the ground across the planet, Earth is overdue for a deposition event of significant magnitude, like in the 80 to 100 range. Even while from a purely time perspective, we would not be overdue or too early for such an event, but right on time. So, what would be a good tiebreaker? How about caldera size? This can be considered ground deformation of the explosive event, and it is clear to see that the holes in the ground have been puny compared to the fairly recent past, where it is clear that the blasts were much, much larger. So, if we may adopt a simple scale for expectation of volcanic events, you want to be in the early period where things are not expected to happen for some time off. On time means it could happen anytime and there is really no way to know when. And of course, overdue means Earth should, by cycle and pattern, be ready to do something soon. Here we categorize the three quantitative measures that can be gleaned from the catalog: time between eruptions, Earth deposited into the atmosphere, and caldera ground deformation from the explosion. We are dancing into that sweet spot in terms of timing. No doubt we are in the early part of it, but also, no doubt we are in it. But in terms of Earth getting out what she needs to get out, it's been a scant production for about the last 1,000 years. Earth is expected to be blasting much more material into the air with a much larger eruption, and it should be statistically expected to happen within about 100 years, with no bias towards one side of that scale or the other. Before we continue, please recall that Pinatubo back in 1991 dropped Earth's temperature an entire degree for 15 months thereafter. Compare that to only the zero point 0.9 degrees of global warming thus far. And now remember that Pinatubo's atmospheric deposition was less than 10 cubic kilometers. A VEI 7 would be 5 to 10 times as powerful, with logarithmic increases in the feedbacks. And let us not forget the nonlinearity of these systems and their dependence on other factors as well. In this case especially, that includes external forcing from galactic cosmic rays. After decades of speculation, two studies this decade have shown the periodicity and amplitude of volcanic activity on Earth to match solar cycles and cosmic ray modulation. This is where you'll need to remember our first episode on energy from space. since the only forecast for that in the future is the modern cosmic ray epoch. That video is linked for you below, and presuming you have done that previous homework, you can see some scary writing on the wall, especially if you have children or grandchildren. The chances are equally likely that many watching this video would see that eruption, and it would be perfectly on time in geologic terms, and possibly overdue in terms of Earth effects. The further into the future you look, you realize that numbers and math make this an inevitable reality with which we must come to terms. That part of the paper and its insistence that we are very much not ready are things with which I certainly do agree.